here to do this. Okay. Did you guys have a nice Halloween? You're too old to trick or treat, obviously. That is true. I ate too much candy, and then, well, I did it in secret, and then my fiance found the wrappers. There might have been some shame. I said, "Wow." Then I felt ill, but I couldn't admit that I felt bad because it was obviously a self-inflicted situation. So. Like I realized at my old age, I got bougie about my chocolate. I can't do the Hershey's anymore. I'm like, oh, I need like fancy, what? Yeah. No, like my low level now is like Dove, kind of got some shame going on a little bit about it, to be honest. Bless you. I heard that there's a flu going around, which is not cool. Anyone suffering from that? Or sort of trying to recover? Good. Stay healthy. Okay. Okay. So reminder that these functions are often used in lieu or in place of for loops. So they are for iterations, for iterating over columns or rows, columns and rows, and a variety of data structures. Storage structures is the right way to say that. Okay, so the first one, we went over this in class, but just to remind you, the first one is aaply. So the first character is the type of data, the input structure, sorry, let me rephrase this. The data storage structure that is the input. So in this case, if it's an A, it would be an array. So aaply, so that means the input is data from an array, and the output will be also an array because the second character in that is also an A. So array. So if we make an array, three, and 3. Let's see if this goes. Oops. There we go. I need you to run and not delete it. So we've got an array here with 30 values in it, where I'll assign some names. Captain Marvel, Iron Man, and Black Panther. Some column names. Spider-Man, Black Widow, the Hulk. And now I realize I know too much about the Marvel Universe. So sidebar. Do you guys have favorite characters from the Marvel Universe? What's the favorite character? Okay, two pretty cool. So they made a lot of Spider-Man movies, and like I'm like a Tobey Maguire Spider-Man fan. I don't know. Yeah. No. Is that the No Way Home one? Yeah.
I used to be a big Tobey Maguire fan.
And then you were like, okay, I can hang.
Yeah.
All right. Who's the new? Is it Timothy Chalamet? Oh. I like how you were like simultaneously horrified and surprised. It's too early for an existential crisis. Maybe around lunchtime. No. What's that? Say that. I can't hear the last part. Okay, I got some catching up to do. I have to admit, I only watch these with the 14-year-old stepson. We don't like, yeah. So, but he's reached a point in his life where he no longer wants to hang out with us. So. Who plays Iron Man? The character's name. Robert Downey Jr. Thank you. Tony Stark. I mean, not wrong. Okay. All right, now we set up our array. Okay, we're going to load up the plyr library. Okay, so here, just to remind you, we're going to use our aaply function. And the arguments, the ones we need to pay attention to are the first three. So the input data is going to be my array. Margins is either going to have a value of 1, 2, or 1 and 2. So 1 being the rows, 2 being perform this function over the columns, or C 1 and 2 perform it over both each row and column combination. So in this case, if we wanted to perform it over columns, we would select value 2. And then lastly, the function. So we can find, for example, the mean. And you don't have to put the closed parentheses, you just put mean here. So I want to make a note here. 100%, absolutely, yeah. So any function can go in there. Okay. In fact, let's do that. I think that's a great exercise here, just to remind ourselves. So let's make a function up. We could use our classic, our temperature ones, which are easy. Do you guys want to do like, what is it? Celsius to Kelvin? Isn't that like 32 minus 270? Someone's gotta look it up. What? You just add. Okay. So 270 plus C. Okay. Do we have a consensus on that conversion? Okay. C to Kelvin. So it is X. Get it together, Kelly. It's 273 plus X. Return Y. Okay. So if we go back to my array, let's call this temp array. So aaply data is my array. We'll do this over the rows this time. So margins equals 1. And then our function is Celsius to Kelvin. So when we run temp array, we will have if you wanted to return a data frame instead of an array, you just say you're going to change that second character from an A to a D. So D for data frame. So it's going to look like this. It's going to be adply, and we have the same input arguments. My array, my margin will be 1. Let's keep this the same. And then we'll just use our function, Celsius. And now we have a data frame. If you want, bless you. If you want to, grammar, Kelly, to return a list, it's AL, so array to list. No. Celsius. Okay. Okay, so what if our input is a list? I'm just making up some data here. Okay, so there's some data stored in R just about like state populations. We just borrowed that for a minute. So our input's a list. So our first character for our function is going to be an L, and we're going to output an array. So here we just asked for a range. You want a list? Output is a list. This is LL y. Data equals my list. There we go. Which one? This one, the top one? Here, is this helpful? Yes. Range is the function I was doing. Yeah. And we'll do the last one. Let's see here. Let's see if we can do this. Oh, that's not gonna work. ggplot. Data is my list. And then we're going to do a summary function. So it gives us a summary. Okay. All right. So where'd you go, buddy? All right. So I use these functions when I'm mostly just, trying to apply like one function over a set of rows or columns. You can see how they'll be useful for a variety of things, what you're trying to do. This next function that's in this family I'm going to show you. Personally, I use it a lot. I find it extraordinarily useful, and it's ddply. So it's data stored in a data frame in and data in a data frame out. I don't really typically work with like arrays or matrices or lists. Lists are kind of awkward, and arrays have their place, particularly if you have multi-dimensional data, but usually I'm kind of working with like flat 2D data. So this is just something that I use. You may have a different story, but we're gonna work on a couple different ways that you can use ddply to kind of help your life. This is the function that I use mostly in place of a for loop. Okay, so to kind of properly demonstrate the usefulness of this, we're going to load up a data frame and not just make some up. So do you guys have access to like the little fish data set? Yeah, from running your exercises. Let's go ahead and load that up. Oh, I didn't set my working directory. Fail. Session. Okay, let's try this now. There we go. Okay. All right. All right. Everyone with me? All right. Okay. So the thing that I like about ddply is that it allows me to basically use grouping functions. It allows me to group, it allows me to split by a variable, perform a function on those sets of those subsets, and then it puts it back together for me. So this is helpful, for example, if you had a data set like we have here, where, for example, if we have different species and you want to find the mean abundance for each group, each taxa, right? So you have the inputs, you want to split it, and then you want to spit it back out as a data frame. So let's look at the arguments here, just real quick. Okay, because these are a little different than what we saw previously, where it was input, where it was data, margins, and then function. So the difference here is variables, and variables is the argument where you tell it how you want your data split up. So let's see here. So data is the input, variables. You can split your data up by multiple variables. And then function is the function you want to apply. Okay, so on a very simple way, we can just apply a single function like we've done before. For example, like mean or sum or our, Celsius to Kelvin function, right? A singular function. So for example, let's try this. This doesn't make, we'll find the mean, for example, for our parcel length category here. And if I'm pretty sure if I test this, we should have 4 parcel types. Make sure that's the case. I believe that is. We sure do. So we're going to find the mean parcel length for each of these 4 categories. Okay. So my input data is the data frame F. It's already been saved. The variables are going to be parcel type. And then my function will be mean. Expected. So now that should work. ddply variables, parcel type. Yeah. Oh, I know why. Dirt. I didn't tell it what I wanted it to take the mean of. That is my error. Okay. Let's see here. Probably misspelled something. All right, let's try this. Function equals summarize. There we go. How do you summarize? Okay. Okay, so we've returned a data frame. It doesn't have a name, but we found the mean parcel length for each one of our categories. So this is not dramatically different structure than the other ply functions. Which way do you want me to scroll? To the right. You guys good? Okay. Let's see if I'm going to zoom out a little bit. For me, it's very smushed on my screen. Let's see. Let's try this. Okay. So, like I mentioned before, you don't have to just use one variable to split your data frame by. You can use multiple ones. You can use 2, 3, 4. How many ever categories you need to do. So in this case, we can repeat this. I'm just going to copy this because we're not going to change much anything else besides adding a second variable here to this argument here. So we have, making sure, I'm pretty sure we have multiple transects. So I'm just going to double check that. There we go. We got multiple transects. So we're going to add transect ID here as a second variable. And that's the only change I've made. I'll wrap this around here so it's a little easier to see. This hasn't changed anything. I just wrapped it around. So now we see a difference. We've grouped by both our transect and our parcel type. Okay. So we just used one function so far in this ddply call, but this next example is really where it shines for me, at least in terms of replacing a for loop, is that we can apply multiple functions within a ddply call. So we've already got our Celsius function. Let's see here. Do we have any temperature data with this? Names? No. Okay. Sorry. We will do this. We're gonna make a new function called column volume. We're gonna find some density of some stuff here. So the function's gonna have, we want to get the volume of a column, so it has 3 inputs: length, width, and height. The volume is going to be equal to the product of those 3. We'll return that value. Let's run this to add it to our environment. Also, I'm going to spell column correctly. Okay. And I'm going to find the volume of each parcel. Okay, so ddply. I'm going to make this more complicated. We're going to do transect and parcel type. So our input data is our little fish data set. The variables are going to be transect ID and parcel type. And then here where it's a little different. Sorry about this. I'm going to scooch this over here real quick. So instead of having like a defined function here, like summarize, I'm just going to put function X. This is essentially like a placeholder. Like when we make up any sort of function, that could be a Y, a K, whatever makes you happy. Okay. All right, so now we're inside our function. So I'm going to do some more work. So the input, like when we're working with our regular functions, I now have to name each split X, right? So each time we have a group of transect and parcel type, that little bit of data is going to be assigned the object value name X. So it's X parcel length. And I'm going to make a new field called kilometer because I'm going to change the units for parcel length M. I'm going to divide it by 1,000. Then we're going to find that volume. So we're going to make a new field called parcel volume. And we'll use our column volume function. So the inputs are going to be parcel length M. The width is, we'll just make this. So this is, I just know offhand, these are constants. This was the dimensions of the camera frame. Don't stress out about it. Okay. So I am doing two separate things here. I am making a new column. They don't have to be related. I'm making a new column with kilometers. And then I'm making a new column with that has the volume values. Okay. And then once that's all for this example, that's all I want to do. And so I want the data frame to be returned. So I'm going to do return X. Okay. So ddply also has some cool little things to help you know how well it's working. We use these arguments after the curly braces. So if you see where my cursor is blinking here on line 77, this is where those little extra arguments come into play. They are optional. I like to use them because it helps me figure out when I'm debugging things, what has gone wrong. Okay, so the first one I like to use is progress. You have to make a comma there. This gives you a progress bar text. So it says create a text progress bar. It's very satisfying when you're processing a lot of data to see it like chunking through. This is unlike a for loop where you would have to basically add some code to like show how well it was doing versus like just watching that little stop sign that happens in this little corner up here. Okay. And then the next thing that helps with debugging is this inform argument, which is a logic argument. So instead of kind of giving a very short, concise error message, it's a lot more verbose and will tell you much more precisely where the issue happened, which helped with debugging. Okay. So it didn't take very long, but we got that little progress bar, very satisfying. And we didn't have any errors, which is lovely. So if we look at our output, wait, did I name this wrong? What did I name this? Yep, that's right. So if we look at our output, it took the data in, it split it how we asked it, and then it added these two new fields. Yeah,
On lot 71.
sure thing. No, I might be going too fast. Okay. All right, so let's practice this on our own. We're going to pick out some different data here. Bless you. We can use transect. Ooh, transect ID. And let's see here. Find the, let's see here. Find the density in per 1,000 cubic meters. So you're going to be working with this column here. So maybe more specific. Split the data frame F by transect ID. Okay. Let's see here. And what else can I make you do? That's fine. Okay. All right. So I just want you to practice that structure. So go ahead and give that a go. Yeah. Error message. Yeah. Try that. Rerun that. So when I have this problem, what I'll do is subset, right? So it's essentially subsetting transitive information type. I will grab like in like on your own, a friend that has like one subset of that, and then start applying something to see where it's failing. Test today. Yeah. Okay, how successful were we? Yeah. Cool. Okay, so this is a very short example, but like you can see the power of being able to do a lot of processing on subsections of data frames. I find this particularly useful when I'm working with really large data sets where R can only handle about, let me get this right. It can only handle around, like in its like scratch memory, I think around 2 gigabytes, which sounds pretty voluminous, but if you got really big data sets, it can kind of bog it down. So often to process these really large data sets, you need to split them up, do the work, and then put them back together at the end. So this is one way to kind of like allow an appropriate amount of scratch space to be used while you're processing your data. We'll see this hopefully next Thursday, because we're going to just now transition to working with graphs. Woo! You can also use ddply to automatically make graphs for a series of subsets of data, right? Oftentimes when we're just kind of doing data exploration, we need to make a bunch of graphs. Sometimes we want to split up by species. We don't want to do that by hand. ddply allows us to make the same kind of graph for different groups of data automatically, which is quite handy. Okay. So before I close and move on to data visualization, do you guys have any questions about the apply, the llapply, adply? Yeah. Oh, yeah, sure. Okay. Yeah. Okay. Do you guys need a minute break to kind of clear your heads? You ready to move on? Yeah. Scroll up, no problem. You tell me when to stop. Because you don't have to. Like if you you can kind of do things line by line, like you do like in your normal R, right? or if you know, kind of your standalone functions are very handy if you're just trying to repeat the same work over and over and over again, right? And so like, it's probably more efficient if you're trying to do something over and over and over again, just write a function for it and use it in ggplot, right? Or use it in for loop, things like that. I have it's not probably that best organization, but I have an R script called just functions, where I store my little custom functions that I have made. And then I know that like when I need to do something, and I'm just going to go back to my functions library and pluck it out to use it. Yeah. So. Okay, so we're going to load up tidyverse because that has our ggplot package in it. All right, let's start simple. Let's just make some point plots. Okay. So we're going to plot parcel start long and parcel start lat. So that will be on the x-axis. Long will be on the y-axis. Okay, so ggplot is a little bit of a different beast because it uses the mathematical operator plus to essentially add data elements to the function. It is, as far as I can tell, the only like Hadley thing Wickham function that does this. So it's a little bit of a different beast. I want you to think about ggplot functions as layering data like a cake. So things that you add first will be on the bottom, then things that you add next will be on the next top layer, and then the things you add again will be on the third layer, so that the very last bit of data that you add will be always on the top, because you can layer visualizations right on top of one another. Okay, so what does this look like? So ggplot. Okay, so the arguments are not very intuitive. There's data, that's awesome, right? But like, what else do we need to do? All right, so data is going to be our input. We're going to use our little fish data set here. We don't need to load anything else. And the next call is called AES, which is short for aesthetics. This is where we're going to set the data that belongs on the y-axis and on the x-axis. This has to go in parentheses. So our x data is going to be parcel start lat, comma. Our y data will be parcel start long. Okay, so this little bit here is like the foundation for all your plots. It is just telling this is the data that you're using to make your stuff at. And then we're gonna start adding something called the geom, which is different types of visualization. So we have geom point, which we'll use now. genome line, genome bar, things like that. I suggest there's a set of cheat sheets on our Moodle course page, and there is a ggplot one. So it may be helpful to download that to kind of see all the different types of genomes that are available to get a sense of all the different flavors. Okay, so again, we add these layers using this plus sign operator. So it's not working like a plus sign. It's like include this thing is kind of the new syntax. Make a note here. So in this thing, here when I type in genome, you see that there is quite a long list, right, of different things that we can do. Dun, 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 so many genomes. We're going to do point. Okay, and we're not trying to do anything fancy. Why is this upset? No. So, what's that? No, because I need to encapsulate, this is one parentheses, and then here's the second one. So this is a standalone little bit. So I don't know why I was mad. I was upset about something. So now it's gone away. So this should work now. Okay. All right, I haven't assigned this to an object. We can assign to an object in a minute. So when you run this, you should have something pop up in your window down here. If you've got files, plots, things going on. I'm gonna hit zoom. Just gonna make it bigger. So this is basically the path that the ship took when we were collecting our data in the Straits of Florida. It's like a poor man's version of a map. Okay. Like anything, we can assign this visualization to an object so that we can save it and use it later. So we can say plot one. Dun, 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 dun. There we go. Okay. All right, so along this idea of layering, we're going to add a line to our point plot. What's that? I just like our normal syntax here. I just did the left facing arrow with the object name. Yeah. This is telling it to make points. Maybe it's kind of hard to see because they're zoomed out real far, but each one of those is there's a series of points. Yeah. And it's fine if we put anything in the parentheses. You can. I haven't gotten there yet. You can mess with the size, the color, the shape. What else? Yeah. So like that's where you set all the aesthetics for your points. Make a note about this. And I will show you how to do that, just not right now. I didn't want to overload on what we're doing here. All right, so adding a line to our plot. Okay, normally I was just copy and paste, but I think it's important that we practice. So we will write this out. So ggplot. Come on, computer, you got this. Data is F. And then where our aesthetics again are X is equal to parcel start flat. Y is equal to parcel start long. Okay, so just like before, I'm adding a plus sign here and I'm adding geom point. And then I want to add a line. So I'm going to have another plus sign and say geom. Oops, I wanted to guess on me. Line. So if you may remember from my kind of introduction of this set of functions, ggplot works in the order in which we add things. So the line will be plotted on top of the points. Because it was added after geom point. Okay. So then we run plot 2. This looks entirely ugly because it connected all the transects, but we added a line. You mean like a regression? Yeah. I really appreciate your segue. Thank you. Okay, if you guys are cool with this, I'm just going to copy this. We're not changing much. I'm just going to change the name of our object here to keep these separate. So I'm going to remove geom line because that's not very informative. And I'm going to write geom, let's see here, smooth. Okay, so geom smooth is like adding, it's the way to add a trend line. There are a few different methods that you can add a trend line to data. So that's why we're going to sneak down here to this method argument. See if I can pull up the arguments for this. Hang on a second here. Okay, I want to be able to see the arguments. There we go. Okay. Oh, stay. Okay. Okay, if you can see on your screen here, it's going to list out a few different methods to add things. So the most basic one that we're kind of used to when we add a trend line is a linear model, which is LM. This next one stands for generalized linear model. This one, GAM, is a generalized additive model. Low S is like your free-form poetry version of a trend line. It's going to go where the data goes. So if the data is linear, the line will be straight. If it is nonlinear, low S will be curved. And so you get to pick how you want your trend line fitted. So it should default, I believe, to low S. But if you want to force it, for example, to be linear, you got to say linear model. All right. So if we pick LM, thank you. So you can see that it's informing us that it's using a linear model here because the formula is X to Y. And I'm going to sneak over here and just hit zoom. And we can see that it's attempted to add a trend line. All right, so let's change this up. This data, if it was actually like real data, it has more of like an exponential flavor to it, right? So let's use low S and see what it looks like. So I'm just going to copy and paste this, and I'm just going to change our method to low S. I copy. So it did its best. Try to fit a line for all those points. Now it's a little hard to see. I'm going to make this bigger to hopefully kind of illustrate that. Do you guys see on your screen, maybe most evident in the upper right-hand corner, that there's a little bit of gray shading there? Yeah. So that's our way of trying to estimate the 95% confidence interval. So that was true. It does this for all geosmooths. Let's see if I can go back here. Zoom. So we're looking now at that linear model that we plotted a moment ago. And you can see the little gray shading. Again, that's the 95% confidence interval. So just note that when your advisor asks, what is this shading and what does it mean? You can tell them. Okay, we are, oh gosh, time flew by today. We are at time. We will continue working on data visualization on Thursday.